Good morning. So today on the bench, these are the, well, in my little world, these are the infamous Seeburg SHP3 amplifiers. I have two of these chassis in the lab right now. I have more boards, driver and preamp boards that I can count that all have various issues, and these would be the solid state amplifiers from the 1970s. So Seeburg Jukebox, Seeburg company was around for a long time, and in about 1972 they put out these SHP series amplifiers. It was SHP1, SHP2, and SHP3, and what you see here are the threes, and they're about 100 watts per channel. The SHP is actually a super high power, that's what that stood for, amplifier. And the SHP1, which was the first in the series, was basically standard equipment in the SPS 160 Olympian jukebox. So they, as a matter of fact, if you're not familiar with Seeburg, and I claim to be no expert, the TV show Happy Days, the jukebox in the intro to that show was a 1952 Seeburg M100C that for the first 10 seasons or so. So that would be a Seeburg. This would be slightly newer than that, in 1972-ish, and they had a lot of problems with the bias control on these amplifiers, all three series. As a matter of fact, one of them, and I don't recall which, had to be redesigned. I think it was the SHP1, because of some fire hazards. But the bias control, while it's not really complex, it's can suffer from some drift, and also there was a bad habit of techs or people working on them that just didn't properly set the bias. The way that you set the bias on these is kind of, I don't want to say bulletproof, but it's a pretty simple procedure. You would take your multimeter, you set it in volts DC, and you would take your positive probe and stick it into the red test point right here, and it will just stick right in there. And then you would touch your black probe, or your common probe, to the back of this the collector. This is the collector on this output transistor, which is a 2N3055, and you should be getting a voltage of between 2 and 20 millivolts DC. And Seeburg was even nice enough to write that right on the chassis, so both channels are the same. And so you just test from here to here and here to here. And the way you would set the bias is there are two potentiometers, I'm not sure if we can see that all the way over there, that are under the chassis, and the adjustments are accessed through the holes, and they're labeled very clearly left and right bias. And the gain controls, actually the gain controls are the holes you can see looking at you. The bias controls are actually on the side, but they're underneath the chassis, and that's for a reason. Once you set those, you put some stickers over them and then basically say, no, don't touch that, because you need a multimeter at least to set the bias. Now, you could set them with an oscilloscope, if you can see the waveform, and then use your multimeter to double check, just to make sure you're not running a little hot. But 2 to 20 millivolts DC is not very much. And unfortunately, there's this problem with texts that say things that really are scary, like, well, I just set it by ear. Well, you can't set it by ear, because when you're setting it by ear, you're overdriving all the transistors, which is going to cause some serious problems, like a fire or melting your see, an overdriven transistor. The overdriven transistors sound really good until right before they burn up. So we don't want to do that. We want to make sure that we're using the manufacturer specifications, and we're just checking the distortion in a waveform. A lot of times, if it sounds a little quiet, muted, or muddy, it could be a whole bunch of different things. Theoretically, in most cases, it has something to do with electrolytics or with the preamplifier board. A amplified crappy input is going to sound like an amplified crappy input. So when there's some distortion going on there, all you're doing is amplifying that distortion, and it just doesn't sound good. So the bias is going to help to correct with crossover distortion. So we definitely need that, especially nowadays. It's just the resistors are going to stick around and hold their their value is a lot longer, so we don't generally need things like crossover bias control, or bias pots in a lot of the newer equipment. But in this stuff we did, because any kind of a drifter, if you replace any parts, you're going to change the values inside of that circuit, and you need to be able to set that bias. So these things had a major problem with bias issues, and a lot of it had to do with the technicians, and a lot of it had to do with where they may be stored at, and how temperatures can cause variations in the even the good, what they could, the roundies resistors, you can still have problems with those. So when these amplifiers came in, I did a quick test to see where they stood. All the component parts seem to be there. Yes, you may notice that this one's missing a couple of teeth, the filter caps. I'll get to that in just a moment, but they were there when it got here. And as was everything on this. So basically the instruction was just go through and make the repair, see what's wrong with them. I'm sure it's something simple. Well, this one honestly just needs new caps from what I can see. I ran a waveform through it. Everything seemed okay. It did have a bad diode in the rectifier, which was repaired. And then this one came along. I moved this one off to the corner and I started to diagnose this one. Now here's the thing. I have a multitude of these driver and amplifier boards that are in some various state of destruction. And I have these two chassis for the SHP3s. So the idea was, okay, we'll take one of these chassis and we'll get it all tuned up and basically make it brand new. And since this one had more problems, I thought, okay, we'll go ahead and use this one, and then I would use that to test all the boards that I'm working on. So in other words, you just pull board out, put board in, and basically this becomes our test fixture, and I can run some signal through it and see what happens. And then this one would be just a comparator until all of this was completed, all the work on this one, and all the boards fixed, and then we would go ahead and do the same with this. Well, we had so many problems with this first one that we never got around to this one, nor most of the boards. Some of the boards have been repaired, but others, most of them have not. And that's what I think we are going to do in this video, is just kind of get familiar with the two, with the amplifiers, and then I can show you some of the things that have gone wrong with Mr. Murphy amplifier over here. And we're just going to X this one out for right now. So where do I begin? I'll tell you what, let me look at a few things and change the camera just a little bit so we can just look at the one amplifier, and I will be right back after I make that adjustment. Okay, so I had already shot everything and then realized I made a couple of mistakes. So I'm reshooting this section because I want to kind of trim it up, make it pretty. So if I cover something a little bit twice, I apologize. There may be a slight overlap. The bottom side of our chassis, this was filthy when it came in, so it all had to be cleaned. And then we inspected. We did a partial inspection when it came in before we cleaned anything to look for any obvious signs of leakage damage. Then we cleaned everything up. So this section would be our power transformer section. Power transformer is mounted on the other side of the chassis. In our incoming wires, we have the rectifier diodes that are right here. We have a couple of resistors, current limiting resistors right there. It's our decoupling. This would be our signal transformer sections, and we have a couple of decoupling caps underneath there. We have another electrolytic hiding. If you follow this wiring harness up, you'll see we have our biasing adjustment pots for left and right, and then across the back of the chassis we have two gain pots, 1 and 2, that are also, all 4 of these items need to be cleaned whenever you go in and do any work on this stuff. One of these was actually assembled wrong. Whoever had this, we had a couple of different problems with the biasing section, and that was one of the issues, is you can actually put those pots back together wrong. And it was only controlling half of the ohm value in the pot. So there's a little tab in there that was reversed, and it was stopping the mechanism from actually turning, so you couldn't get full adjustment on the pot. So I cleaned that up and put it back together, and That's now working correctly, but we still had a problem, and I will get to that, with the entire section biasing. The bias, even after everything was cleaned up and everything should have been correct, after this whole thing had been gone through and many parts replaced, we had no control, no response from either bias pot when adjusted. So keep that in mind for later. All of our FETs were replaced. These are PNP and NPN. They're color coded on the original part, but we had to upgrade. And Seeburg, there are several Seeburg not manuals, but parts lists that will give you the equivalent parts. And I checked everything against the data sheets, and these were definitely superior to the older FETs that were used. All of our transistors in the driver board were replaced. Our electrolytics were all replaced. These were actually, this board came in with these on. Most of the resistors on this board were not replaced, at least not by me. I did replace that one, and a couple. I think this one might have been replaced by somebody else, because that looks like a metal oxide instead of a. Yeah, that's an older one, but not very old. So these things, obviously, over the years, they've been worked on a lot. And you'll notice what people would say, well, that's a bodge job. Yes, that's kind of a bodge job. The thing is, this bodge job was actually performed by Seeburg. Seeburg, these junction connectors had some problems. So to rectify the fact that they weren't making good connection on these specific traces, Seeburg drilled little holes through the PCB and just ran a jumper wire from the bottom side of the connector right into the board. And I have an example of one of those right here. This is one of the several boards that I have that needs obviously some work. Needs all the new capacitors, and missing a driver right there. We're missing some things, and then it's also got a burnt trace, and somebody put a wire on here, which, you know, this would have done the job, but it just was having some issues, and it looked like there was some damage done up in this section as well over here. So to illustrate, see if I can turn this board so you can see these pins are just drilled. You know, they're just drilled right through the circuit board, and they've added these pins which would have been soldered to the wire. But you can see these things have obviously, whoever took this board out, they either just pulled the wires out, or maybe they did desolder them, I don't know. But it's just direct soldered right to the back of the trace, just drilled right through. So that was what Seeburg said to do to fix the problem. They actually sent boards back to Seeburg, and they did that. So that is what the majority of some of these, you know, boards will look like. So again, this is the driver board. I think that is everything that I wanted to cover on the bottom of the chassis on this first board. And then the second portion of the video has been shot. So I hope I didn't forget anything, because otherwise the second part will look really confusing. So we'll go ahead and go to that next section right now. Okay, so I'm just going to give you a quick glance here. You can see our first connector is now dropped. Oh, it's leaning a little bit. It is now dropped from the amplifier. Still connected. But let's set this back down just like that. Okay. And then these are our kind of plastic standoffs that stick through. Pretty cool idea back in the day. And then this, so as we're looking at our amplifier board, you notice we've only got about 4 electrolytics on here. But again, these have to be changed, because these are in the preamp section, and these are upgraded. You'll notice that this board we're seeing some much different things going on here. None of these are the original resistors. These original resistors, these resistors have all been replaced with nice film, metal film resistors. These are all new capacitors. As a matter of fact, in the entire board, I see I see 2 of the original, 3 of the original capacitors. There's a 4th and a 5th. You would think that I'd know this board a little bit better, but I don't, because I see a lot of them. And these transistors have not been replaced. Now, they're not the originals, but I remember looking at these before I tried to power this up. I selected these boards that are in here because they were the closest to being correct and ready to go. They needed very little work, and when I started having problems with that bias control circuit, I could tell that the you know, our NPN FETs up here, they had seen better days at that point, so we replaced them all, and we still had some problems with the bias control. So we need to, this amplifier sounds very muddy, and since most of the electrolytics in here have been replaced, I am going to try replacing these last two electrolytics on that first board, but I think the problem is going to be here in the amplifier section and the preamp section. These transistors, if not matched, will cause some pretty bad issues, and making this thing sound like it's got some distortion and just overall muffle is definitely one of those things. It's going to be a lot less efficient, and it's going to have some noise problems. And this thing sounds very much like somebody threw a wet blanket over the speakers and is trying to play it at full volume like that. So we're going to go ahead and that's going to be for the next video. I think we're going to go ahead and set that up for the next video. But in this video, there's one last thing that I did want to cover, and it has to do with the biasing circuit. So without breaking out a schematic, our bias control pots need to function in order to set the bias, or we are going to overdrive the transistors, which again is very bad. And inside of the channels on the bottom side, there are a couple of what Seeburg called stubistors, and those stubistors are just I don't want to give it away yet. I want to tell the story slightly different. Those stubistors are what a couple of people that are close to Seeburg have called signaling diodes. Just a couple of signaling diodes in series. To put that very specifically, what they are is actually one of these. Let me get my tweezers. I have one sitting right here for inspection, but it's buried a little bit. Okay, let's see if we can get the camera to focus on this. And you'll see that is a very small blue glass passivated diode. Maybe you can see that here. Let's get some more light on the subject here. There you go. Now, one of these was really burnt up, and of course we had no idea what this was. I mean, I haven't been doing these types of things, these types of amplifiers for very long at all, and I had no idea what that was. It was a blue diode. I'd not seen one before. It's certainly not surface mount, so what the heck could this possibly be? It's glass passivated. It certainly looks like a diode. But whatever is it? And some of you guys might know it right away. But if you do, you're smarter than some of the smart people I know, because they looked at it and said, I don't know. One of the smartest people in the world I know said, well, that's probably a proprietary graded diode of some nature, a proprietary component, small signaling diode. And that would be the key. Small signaling diode is how you would replace that. So in the manual, Seeburg just calls this a stubistor, which when they say stubistor, they actually mean two small signaling diodes in series. So two small signaling diodes would actually be two of these, which looks a lot like a Zener diode, but it's not a Zener diode. Anybody want to take a shot? Any guesses? If you said a 1N4148 switching diode or small signal diode, you would be correct. That is exactly what that is. So the problem that we had was this one is marked, no real filter, no real focus on there. The blue stubistor Seeburg diode was burnt up. All of them were in this amplifier, so there was no way to see exactly what they were. Well, replacing this with a couple of signaling diodes does not give you the desired effect. And the desired effect was that even after everything was rebuilt, all the pots were cleaned and everything was totally gone through, no more shorts, no more issues. We could not set the bias. It would not set at all. And that was when I realized that I had made a mistake somewhere. And going back through everything, I realized that the diodes that I replaced those with were not, in fact, small signaling diodes. They were just signaling diodes. So, replacing that, now we have everything working, except we still have this muddy sound. So, the attempt was to, transistors, they can go, they can leak, they can cause all kinds of things, but the idea was some of these are pretty good audio transistors, and we attempted to leave those in to see what the difference was. Well, I can tell you, if it's what I think it is, this amplifier sounds very, very muddy, and I think that has a lot to do with it, are these other transistors. Of course, I'm going to have to go over it and make sure we didn't miss anything, or maybe somebody put some wrong values in somewhere. I'll go double check that all again. But I think for right now, that's going to pretty much end it for this video. And in the next, I'm going to label this one part 1, and in the next video, I'll show some of the diagnostics and testing, or I may just go ahead and rebuild it. I may grab some video of the test just so you can see the waveforms, and then we'll change out all the transistors, and I'll do some more diagnostic work, grab some film of that, and then we'll see what the hopefully finished product was or will look like, because I really want to get this sucker off of this bench. I mean, this thing has been causing me nightmares and grief for months, and when I have worked on it, and I want it done. Believe me, nobody wants this done more than I do. So, with that, I appreciate you watching the videos. I hope you learned something. I hope if you were looking for some information on the inside of this amplifier, you got it, and there will be more to come with some more videos featuring the wonderful Seeburg SHP3s. And until next time, I hope you have a wonderful day. See you in the next video.